Okay, I'm going to record us doing the LightBoard FRQ. Part A is doing that constructor for the LightBoard. So public LightBoard with int. Pretend I know how to write things. Try that again. Rows and int calls. So we're given those names. We have to use those names. So we're given our 2D array lights. Let's make this a new Boolean array with num rows and num calls. So, what is the default value for a Boolean? False. Default value is false. So we can keep that in mind when we are choosing whether or not to turn lights on. So if like we're going to essentially flip a coin, it's not exactly a coin, it's not 50-50, but roll a die, whatever. We have a 40% chance of turning on a light, and if we don't meet that probability, we actually don't need to do anything because the default value is false. So within here, we want to loop over all of our rows and all of our columns, so we look at every index. So doesn't matter what kind of loop we use for the outside loop. We can use a for each or a regular for loop because we're changing only individual elements within the rows. So I'm going to use a for each loop on the outside. So for a Boolean array row in lights, and we're going to do for int I equals 0, I less than num calls.
Do we know if num row and num call are the same?
I don't think all we know is that they're both bigger than 0.
So they could be different numbers.
They could be different numbers.
I mean, I guess that doesn't.
I mean, we could have a tall, thin board. We could have a short, long board.
So just to be safe, use the right variable where.
Yes, use the right variable where applicable. This isn't like that square one.
Yeah.
Where we knew it was the same size. We could use it interchangeably. Here we know they could be different sizes. We know it's going to be a rectangle, but we don't know if it's a square.
Okay, that makes sense.
So I plus plus. How do I make a flip? How do I check? How do I do a random value? I'm going to call math.random. So math.random. What is this going to give us?
Double between 0 and 1.
It's going to give us a double between 0 and 0.99999 repeating.
Yeah.
So what can we do with the value we get from math.random to check if we have a 40% chance?
We could either make it on a scale of 100 or just check if it's greater than or less than 0.4.
So if this that we get is less than 0.4, right? That should be 40%. So, no, oh wow, that's not what I wanted to do. Back to movie, please. Make it a little bit smaller. So, if that's true, then we will say lights. Wait, oh wait, I don't have my 2D array yet. Oh wait, I do have my 2D array.
No, wait, how does math.random turn to Boolean?
Math.random less than 0.4 is my Boolean.
Oh boy.
No worries. So if math.random is less than 0.4, lights, and actually, we're going to use our row variable that we're working with. Row at index I equals true. Close all our curly brackets. And I think that's all we need to do in our constructor. Initialize each of those values. Would less than or equal to 0.4 also work? That's a great question. Actually, so if we want a fully 40% chance,
You have to do 0.41. Right now,
would we want to include 0.4 in our anywhere between 0 and 0.4, I think inclusive. So I think you'd want to do less than or equal to.
yeah.
So yes, I think less than or equal to is what we want to do rather than less than. Good catch. Thank you.
Wait, but you can't get a chance of 1, like, so therefore shouldn't it be less than?
Ooh.
Because it's 0 to 0.9 into infinite.
You're right.
Questions. Well,
The question is, how does probability work? I think the easiest
the
way to,
highest you can get with whatever we had is 0.3999999. If we get 0.4, it would not work. It'd fall out of the thing.
yeah. So if we had 0.4 before, it would fall out of the if. I think the easiest way to do this is just convert it to an int.
That's
So
yeah. Multiply by 100.
int of, or yeah, let's do math.
Just multiply by 10.
Or math, yeah. Math.random times 10. So if this is less than or equal to 4, or less than 4.
Yeah. No.
Because
This goes up to 9.
this goes up to 9 starting at 0. So 0,
Right,
1,
okay, so that's
2,
enough.
3, 40% chance.
Right.
Okay.
There we go.
So I think we do want the less than if we kept it the way that we had it. So we can do a bit of an interchange here if we want. We could use either this or this, I think, here interchangeably.
To be honest, let's just hope that that's not one of the scoring point things.
Let's look at the rubric and see what it has to
I
say.
think if you put less than or less than or equal to, it probably get it to you, right?
Probably. All right, this is the last question, so let's scroll way down. Where's the rubric on this? Rubric, here you are. Creates a new Boolean num rows, num columns, and assigns to variable lights. Did that. Will not earn a point if they initialize a local variable that is never assigned to lights, omit the keyword new, or use a type other than Boolean. So you gotta do it correctly. Accesses all elements in the created 2D array without bound errors. They earn the point even if they fail to create lights, but assume lights, num rows, and num columns exists. So short. Computes the 40% probability. They still earn the point even if they use math.random less than or equal to 4.
Perfect.
So either way, we would earn the point here. They will not earn the point if they incorrectly cast to int. So if we cast to int incorrectly, if we tried to do it before we did that multiplication, we would not earn this point. But in either of those scenarios, we have we're correctly casting to int, or we're just not using an int
We don't
whatsoever.
need to cast it, right?
We don't need to cast to int. Yeah, if we just do math.random less than 0.4, that will be fine. But yeah, less than or equal to 0.4. Either way, we earn the point for this one. And last one sets all values of 2D array based on computed probability. They earn points even if they only assign true values, which we're doing because we know that the default value is false, so we're just not worrying about it. Responses will not earn the point if they compute a single probability but use it multiple times, or reverse the sense of the comparison when assigning. What?
I think you do false.
I think if you do it backwards, yeah. You will not earn the point. I don't know. Will negative points here if we have array or collection access confusion. So here we have a 2D array rather than a 2D list. So we want to use our square brackets, not our get method. If we have any extra code that's printing extra things out, which we don't have, but unless a program or unless a question asks you to print something out, don't have any print statements. And then local variables used but none declared, we don't have any of that. Another negative one is destruction of persistent data, changing a value referenced by a parameter or a void method or constructor that returns a value. Our constructor doesn't return anything, so we're good. So let's look at their example. Now it's even simpler than what we have. So we've got our set lights equals new Boolean num rows, num columns. That's the same. We've got our for int row int for int c is less than num rows, less than num columns. Double random equals math.random. Lights at RC equals random less than 0.4. So that's going to give us true or false. We'll assign that value to that position in the 2D array. So yeah, they don't even have an if statement. But we have an if statement, and that's fine. Our code will still work. This is totally okay. So there is one part here. I'm going to save this before I delete it. Okay, and we're going to clear and look at the next section. Part B, write a method evaluate light, which computes and returns the status of a light at a given row and column based on the following rules. If the light is on, return false if the number of lights in its column that are on is even, including the current light. If the light is off, return true if the number of lights in its column that are on is divisible by 3. Otherwise, return the light's current status. Boy, howdy. Okay, so lots of checks to go on here. We're not given any helper methods, so we don't have any other methods that we would need to call from this one to make sure it works.
So if it's true, you return false if there's even number of truths.
So yeah, our little truth cases here. If on, we have two options. Numbers even equals true. If it's off and our number is, no wait, that previous one returns false, excuse me. Number mod 3 is 0, then that equals true. And if we don't fit either of those cases, then we return light's current status. Okay. So let's implement this. Let's find an open area. Oh, the nice open area is up there, and it's not easy to reach with still having information on screen. Well, we make do with what we have. So we have our method evaluate light. Actually, let me take a look at what this signature looks like. Public Boolean evaluate light, int row, int column. Okay. Yeah. Public Boolean evaluate light, int row, int column. Oh, I'm giving it right here. I didn't scroll down. So we want to do, there's two potential cases here. Light is on or light is off. So if our lights,
Oh, we need to check with one. We've been given the index.
yeah, we're given the
okay.
index. So yeah, given that index, we're gonna do this sequence of calculations for that specific light. So if light's at a specific row column,
Slightly easier than what I was thinking.
yeah, so it's not super difficult.
Yeah.
It's just a bit of stuff to do. Actually, in both cases, we're gonna need to know the number of lights in that column. Let's just calculate that outside so that we have access to that value in both. So this one's going to be similar to our get column method from the previous 2D FRQ we did.
We need the number of what? Number of columns?
Number of lights that are on in the current column. Yeah, we want both of them care about number of lights in its column that are on. So we're going to loop for int I equals 0, I less than lights at lights.length. We want to count the number of rows. I plus plus. Oh, I didn't make a count variable. No, I don't want to resize. We'll make an int column on, set it to 0. We're going to have if lights at I call, then call on plus plus. Or that's written colon, whatever. Okay, so that will count the number of lights that are on in my current column, because that is useful for both of our if statements below. One thing to note, I don't think I've mentioned this, people have asked, what happens if I forget a curly bracket? What happens if I forget a semicolon? Someone fortunately looked this up in another class and has told me what happens. I should have looked it up myself, and I didn't. I'm sorry. If you forget a curly bracket, if you forget a semicolon, you will not be docked points as long as it's pretty clear where things belong. Like here, even if I don't have a curly bracket at the end of this if statement, I can see with this indentation, that thing belongs inside of the if. So if it's pretty clear where things belong, where things are, you don't lose points if you forget a single semicolon, if you forget some curly brackets. So if that's something you're worried about, hopefully that alleviates a little bit of worry. So if lights at row column, so if the light is on, we want to check if the number of lights in the column is even. So we're going to do another if. We're going to check if column on mod 2 is equal to 0. We are going to return false. Close that if statement. And you know, we can just do the else, because when neither of these things happen, we're going to exit both of that if else, and we'll just return the value of our current light.
If doesn't happen either. Then we have
So-
to return the
So we're going to do an if, we're going to do
mouse.
an else. So here we have if the light was on. So here's if the light was off. Within here, we're going to do that second condition. If we never hit either of these ifs, if we don't enter, we're going to exit the else. And out here, we can return lights at row column. So if we don't get into either of those if statements, we'll just return the value we get as it requests. So let's erase this and these. So what should our else have inside? We want to check if the number of lights in the column is divisible by 3. So if our column on 3 is equal to 0, we want to return true. And that's all we need in that else. And at the very end, we'll return lights at index row column. Now, we could absolutely have just an if and an else in here. You could have an if and an else in here that return lights at row column. I only have it once to kind of reduce redundancy because it works just the same. But if you chose to implement it the other way and it still works, absolutely golden. There's not a problem if you have more code than this. This is not the only valid answer. This is a valid answer. All right, so let's take a gander at our rubric real quick. I deleted a curly bracket by accident. So let's take just a quick little look-see at our part 2. All right. Point 1, accesses an element of lights as a Boolean value in an expression. Yeah, we definitely access a single element. We will not earn the point if we access lights as a type other than Boolean. We use it as a Boolean. 1 point for traversing the specified column of a 2D array. We get 1 point for counting the number of true values in that traversal. We can earn a point even if we access too many or too few items in that column, access a single row instead of a single column. So if we don't traverse the right thing, but we're still keeping track of how many trues we see, we will earn a point. But we will not earn a point if we count something more than once. So our loop here, we're never going to access the same element twice. We're just going down a single column. So that one is fine. 1 point for performing an even calculation and a multiple of 3 calculation. You will not earn a point if you use division instead of modulus. So both of those require a modulus to work correctly. So there we go. And last returns true or false according to all 3 rules. Responses can earn the point even if they have an incorrect column count but use the correct logic. Responses will not earn a point if they fail to return a value in some case or implement the counting loop more than once with one loop that is incorrect. So in the code that I've written, I only have my counting loop once. You could have that inside of each of your if statements if you wanted to. It would be a little redundant at that point, extra writing that you don't need to do. But if you have it in multiple places, just make sure it's right in both places. And those negative points are the same as the previous one. So there is our answer for question part B. Hope that was clear. We'll save this as well. I'll upload the images I took, and I'll also upload the recording of today.
Please remember to socially distance during lunch.